Okay, so 6.1, we're going to do the derivative of all trig functions. Students will be able to take the derivative of all the trig functions. So for now, you've just learned these ones, sine and cosine. But what we're going to do is we're going to do tangent, cotangent, secant, and cosecant. And so it sounds like a lot, but there's actually a really simple pattern here to remember, and it's pretty straightforward. So you already know these two, and you know that there's kind of this circular pattern going on with these two. But check it out. Tangent is just secant squared, and we could go through the derivatives and prove this, but tangent is secant squared. Well, the cotangent, or its cofunction, is just the opposite. See, this is positive, this is negative, just like this is the positive, and then this is negative. It's the negative cofunction of secant. So instead of secant, it's cosecant. So it's negative cosecant squared of x. So if you know tangent, you can easily find cotangent, because if tangent is secant squared, then cotangent is negative cosecant squared. And secant is just secant x times tangent x. So therefore cosecant must be negative cosecant times cotangent. Pretty easy. So if you know these three, you actually know all of these. And you should already know this one. So really you just have two that you have to remember, and then remember that the cofunctions are going to be the negative cofunction derivatives. And so here we have secant and cosecant, therefore its derivatives are going to be the negative cofunction. So secant, negative cosecant, tangent, cotangent. All right, so let's just apply this. This first one, this is stuff that you've already done. First thing I would do, though, is I would write this as, instead of sine x divided by 5, isn't this like saying 1/5 of sine x minus cosine x? And so the derivative, pretty straightforward. We can put the coefficient out in front, that's 1/5. Derivative of sine is cosine, minus derivative of cosine is negative sine. And so we end up with a double negative, so that's a plus, and that's all there is to it. It's pretty straightforward. Let's go to the next page. Okay, so we have a cotangent here, but this is not that hard of a problem. So you got y prime equals the derivative of x, so that's just 1. And the derivative of cotangent, remember the derivative of tangent is secant squared, so the derivative of cotangent is negative cosecant squared x. And so you would just write 1 minus cosecant squared x. Now, this is actually an interesting situation here, because you're gonna see this a lot, like a 1 minus or a 1 plus, and I want to just do a quick review. If you remember your Pythagorean identities, let's just go over here and think about it. You know, remember you had your sine squared x plus cosine squared x. That equals 1. And if you went through and you divided all of these by, let's say, sine squared x. That would be 1 plus cotangent squared equals cosecant squared. Well, let's look at what this answer is here. It's 1 minus cosecant squared, so I bet we could manipulate this to get a 1 minus cosecant squared. All right, I could subtract a cosecant squared, and so then I would get 1 minus cosecant squared x. And I could also, I'm going to actually just do this right, I could also subtract a cotangent squared x. Sorry, I'm writing it all nasty. And so these would cancel out and these would cancel out. And so I would have equals a negative cotangent squared x. So my point in this is, sometimes you're going to get something like this, and you got to be able to recognize that that's equivalent to negative cotangent squared. Because if it's a multiple choice, this might actually be the answer choice that they're looking for, and this might not even be an option. So you got to be able to go back and forth between these two forms using your Pythagorean identity. Fun stuff, right? Okay, so let's look at this next problem. We got h of x here, and we're going to do the derivative of cosecant x over x. Now this is technically a quotient rule problem, so I'm just going to write this up here for us to remember: a prime b minus a b prime all over b squared. So first thing we've got to do is do the derivative of cosecant x, and if you know the derivative of secant x, you can find the derivative of cosecant x pretty easily. So the derivative of cosecant x is negative cosecant x cotangent x. And we're going to multiply that by the bottom. So this is just being multiplied, go like this, by x. And then we're going to subtract the top, which is cosecant x, times the derivative of the bottom, which is just 1. And all of that over the bottom squared, so that would just be x squared. All right, we could probably clean this up a little bit if you needed to. One of the things that I see is that we could probably factor out a negative cosecant x from each of these. So maybe an option would be something like negative cosecant x times x cotangent x minus 1 all over x squared. So it's not pretty, but it is the derivative. All right, let's go to the next one. This is a product rule. I think you can do this one. So I'm going to let you guys try this one on your own, and then pause the video and check back when you're ready to see how you did. Okay, so product rule looks like this. So a derivative of the first is just 1, then times tangent x plus the first, which is x, times the derivative of tangent x, which we know is secant squared. And that's it. That's pretty much all you got to do for that one. Let's go to the next page. All right, now we're getting some fun stuff here. But this is there's no quotient rule or anything here, so it's not really that complicated. So what's the derivative of secant? We should know that one. It's just secant x tangent x. And this square root 2, although it looks intimidating, it's really just a number. It's just a coefficient. So I'm just going to go ahead and write my coefficient there. And then what is the derivative of tangent x? Well, it's secant squared x. So this, you're pretty much done here. You could factor out a secant x of both of these, and that would look like this. So there's a couple different ways you might write this, but the derivative itself is actually pretty simple as long as you know your derivatives of all your trig functions. All right, let's go to the next one. We have a tangent of 2x here. So just so we're clear, this is saying the tangent of 2x. So kind of think of that as parentheses. That tells me that I have a function inside of a function. So I'm going to do a little chain rule. Let's say u equals 2x. Therefore, du would equal 2. And you could even say maybe 2 dx just to kind of do everything properly. And so if y now equals the tangent of u, you should be able to do the rest of this on your own. So go ahead and give it a shot, and then check back when you're ready to see if you did it right. Okay, so I got y equals tangent u. The derivative of that would be, or dy would equal secant squared u du. And I just plug everything in, secant squared 2x times 2 dx. I can move the dx to the other side, giving me my actual derivative, and 2 secant squared 2x. All there is to it. Okay, pretty straightforward. Just got to memorize those derivatives. That's all there is to it. See you guys on the next video.